first type of triangle that we're going to deal with is called a 45, 45, 90. What that means is the angles of the triangle are 45, 45, and a 90, or right angle. And these are also referred to as isosceles right triangles. And when you're dealing with an isosceles right triangle, the fact that the two base angles of this isosceles triangle, so you're looking at equal sides, because these angles are equal, that means the sides opposite them are going to be equal, or you're dealing with an isosceles triangle. Okay, and so if you look at the pattern for this, if we assign the leg to be a length of x, what does that mean the other leg would have to be? The legs are equal, so also an x. And then if we were to apply Pythagorean theorem on this, we would get the sum of the squares of the legs, x squared plus x squared, has to equal the square of the hypotenuse. So let's take a look and see what the expression in terms of x would be for the hypotenuse. So if we solve for c here, combining our like terms, and then extracting the square root, we get square root of 2 times the square root of x squared, which is just x, is equal to c. And so if I move the x in front, just to reorder the number, we get our pattern of x root 2. So this is the pattern for a 45, 45, 90 triangle. If you know what the lengths of the legs are, the hypotenuse is just that length times root 2. If you know what the length of the hypotenuse is, the length of each leg is just the hypotenuse divided by root 2. Okay? And so there's one other thing to keep in mind on this, and I'll talk about it in the next slide as well. But if you divide by root 2, dividing by root 2 is equivalent to dividing by 2 and multiplying by root 2. So if you are given the hypotenuse and you want to find the length of the leg, you can either divide by root 2, or you can divide by 2 and multiply by root 2. Those are equivalent operations. Okay? And again, as I talk through the pattern here in a second, we'll see which one of those you choose to apply. All right, so we have lots of examples here. Okay, we're going to kind of go through them quickly. You don't need to write the A, B, and C. If you just draw a triangle and just leave those blank, you can easily fill it in. It'll save you some time in writing as well. Okay, but what I'm going to do is I'm going to go through a bunch of different cases of triangles, and you should be able to eventually see the patterns and how they evolve and apply in this type of triangle. Right? So all of these are isosceles right triangles. So if the length of one leg is 2, what does that mean the length of the other leg is? 2, and then the hypotenuse would be 2 root. Again, the pattern that we're looking at is x, x, x root 2. So if you have 2, 2, 2 root 2. So you're just going to take the length of the leg, multiply it by root 2, and that's your hypotenuse. Okay, so if I give you the other leg as 3, what does that mean the second leg is going to be? 3, and the hypotenuse would be 3 root 2. It just fits the patterns. Okay, so you don't need to go through and solve Pythagorean theorem every single time you come up with or come across one of these triangles. It fits a special form that has a specific pattern, so learn to apply that pattern. Okay, so this is the easiest way that you can possibly be exposed to these. Okay. Next, what if you are given the leg, but the leg's an irrational number? What can you do? Okay, so if one leg is 4 root 2, that means the other leg would also have to be 4 root 2. And then the hypotenuse is going to be that leg times root 2. So if you were to take 4 root 2 times root 2, you do need to recall or become familiar with working with radicals. Root 2 times root 2 is root 4, which is 2. Anytime you multiply a radical, a square root by itself, you're just squaring it, right? So that square is going to cancel the root and just leave the base number inside. So 4 times 2 gives you 8, and so these would be your missing values. Okay, so the next example, if we are given a leg of 3 root 2, the other leg will be same thing, 3 root 2, and the hypotenuse is going to be 6. 3 root 2 times root 2, which is 3 times 2, or 6. Okay, what if we apply that same pattern, but now it's not a root 2, it's a root 3. So 2 root 3, what would the other leg be? Legs are equal, so 2 root 3. And then the hypotenuse is going to be 2 root 3 times root 2, which is, so 2 root 3 times root 2. anytime you multiply radicals, you just combine their product inside one radical. So this becomes 2 root 6. You can't simplify the 6 at all, so you just leave it as that. Okay. All right, questions on that pattern. So that would be the second level of difficulty. If you're given the leg, but the leg's not in the form of the pattern. All right, next we move to you're given the hypotenuse. But if you're given the hypotenuse and it's in the form of the pattern itself, so x root 2, so it has the root 2 form, then what do each of these legs have to be here? Just the 4, right? It fits that pattern. Another way to think of it is the first way I talked about. To move from the hypotenuse to the leg, you divide by root 2. Okay, so if you could just take 4 root 2 divided by root 2, those root 2's cancel, leaving just the 4. So what about this example here? 15 root 2, what's the length of each leg? Again, it fits our pattern, x root 2. Very specifically, makes it nice and easy to work with. Okay. All right, now let's jump down to this one because it's formed on, or it's based on the exact same rule here. And that is if you're given the hypotenuse and you want to find what each leg is, you simply divide by root 2. So what is 5 root 6 divided by root 2? 5 root 3. Again, you just combine the quotient, the division, under the same radical. So 6 divided by 2 leaves a 3. So you get 5 root 3, and then the other leg will be the same. Okay. All right, so again, as far as the progression of difficulty, we can keep moving up. The most difficult one, the most difficult pattern to recognize in dealing with the 45, 45, 90 triangles has to do with the hypotenuse that's not in that radical form. And the reason for that is a lot of students don't understand the idea that dividing by root 2 is equivalent to dividing by 2 and multiplying by root 2. Okay? We call this rationalizing the denominator. Do you guys remember doing that in algebra when you divided by square roots? Okay? Later when we get to pre-cal prep stuff in this class, we're going to be doing that in a more complicated forms, but you'll see it again. Right now, if you don't understand the process, at least understand this relationship. If you can't just divide by root 2, what you can do instead is divide by 2 and multiply by root 2. So here, if you're given an isosceles right triangle and they tell you the hypotenuse and it's a rational number, all you need to do is divide that number by 2 and multiply by root 2 to get each side length. So if the hypotenuse is 16, what's the length of each side? 16 divided by 2, which is 8, times root 2. So 8 root 2. Now think about it. If we go back and check it, the pattern is x root 2. If you took 8 root 2 times root 2, would you get 16? Yeah, so it's consistent with the pattern, okay, but we use this shortcut form. Okay, so let's look at this second example. If the hypotenuse is 20, what does that mean each leg is? 20 divided by 2, which is 10, times root 2. So 10 root 2 would be the length of each leg. Okay, what if you're dealing with an odd number? The pattern still works. You simply get a fraction as your answer. So if your hypotenuse is 9, we still use the same rule. Divide by 2, so 9 over 2, times root 2. And you can leave it in this rational form, this exact number. 9 root 2 over 2, 9 root 2 over 2. Okay, try not to mix number types. So even though 9 halves is 4.5, 4.5 is a decimal or an approximated value. I mean, even though it's an exact, it ends, it's a terminating decimal, it's considered kind of an approximated value with a decimal in it. Whereas if a number has a radical in it, it's considered an exact number. Right? And so don't mix those two display types, again, as your TI-89 would display them. So don't put 4.5 root 2. Now, if you just had to find the numerical answer for these, it doesn't matter the form that you enter it. But if you're writing your answers, write it either in exact form or in the decimal form, only if it asks you to round to a certain decimal. Okay, so the last example here, again, an odd number for our hypotenuse. If the hypotenuse is 15, what does that mean each leg is in a 45, 45, 90 triangle? Take 15, divide by 2, multiply by root 2. So 15 root 2 over 2. would be the length of each leg. Questions on that pattern? No, so if you can simplify them, so like if it was something where this was 16 over 2 and you can reduce the fraction, like try to reduce it, but don't simplify them by putting decimals mixed with radicals.